Good morning, everyone. In the last class, we have seen the derivation for symmetrical Z and Y matrices for reciprocal network, right? So that is, uh, we have shown in a reciprocal network the impedance Z and the admittance matrices are symmetrical. So we have come up with the equation Zij is equal to Zji, and for admittance it is Yij is equal to Yzi. This shows that the Z and Y matrices are symmetrical for reciprocal network. And we had also seen in the last class it is scattering or S matrix representation for multi-port network, correct? So we have derived how we can represent the S matrix for a multi-port network, correct? So, and we had also seen the power losses in the multi-port network or the microwave network, that is your insertion loss, reflection loss, return loss, and etc. So in today's class we'll see what is an S matrix exactly. Okay, we'll see what is an S matrix, what are all the parameters it comes in the S matrix. Okay, so today's class will start with introduction to S matrix. Okay, so we have seen this, what is S parameters. So it is dealing with the amplitudes of the incident wave and the reflected wave in a microwave network. So generally we say S parameters are mostly used for the networks which are operating at radio frequencies and microwave frequencies. So S parameters are mostly used for the networks operating at radio frequency and microwave frequencies where signal power and the energy considerations are more easily quantified. So you are more easily quantified than the current and voltages. This we have seen while discussing the limitations, correct? Here we are not considering the currents and voltages. We are more interested in power and energy of the network. Okay, so S parameters are mostly used for radio frequencies and the microwave frequency networks where signal power and energies are considered than the currents and voltages. So we see S parameters are refers to scattering matrix of your microwave network. Okay, so the scattering matrix is nothing but your mathematical construct or the construction that quantifies how RF energy propagates through the network, propagates through the multi-port network. Next, so what are S parameters? These S parameters are complex numbers. S parameters are complex numbers which have both magnitude and, so Since it is a complex number, it has both magnitude and phase. So the real part indicates your magnitude and the imaginary parts indicate the phase. Okay, because both the magnitude and phase of the incident signals are changing by the network. Why this is these are taken as complex numbers? Because your magnitude and I said no, this s parameters are relating the amplitudes of the incident wave and the reflected wave. So here the magnitude and the phase angle of the incident wave will be incident wave will be keep on changing with the will be keep on changing. Okay, that's why we are considering here the s parameters are complex numbers. Okay, next, the x parameters are usually displayed in a matrix format. S parameters are usually displayed in a matrix format with the of rows with number of rows and columns with number of rows and columns equal to the number of ports. Okay, so next, say for example, for the S matrix I have, for the S matrix or S parameter, if I write it as, so generally if I write it as Sij, so what is this I subscript represents? The I subscript stands for the port that is excited. So this I represents the port which is excited. Or you can say it is as input port. And the J subscript, this subscript represents port which is giving the response, or you can say it is an output port. So okay, this I said generally. Say for example you have S11. So this S11 refers to the ratio of amplitude of the signal that reflects from the port 1 to the amplitude of the signal with respect to the input at the port 1. So here you are taking both the input and the output from the port 1 itself. So if you have 1, 2, so you are getting the reflected wave for the input which is given at a port 1. So this is I and this is J. The subscript I represents the excited and J is your response. So always I will represents the input and J will represents the output. Okay. Coming to the diagonal elements. So parameters along the diagonal of the S matrix are referred to reflection coefficients. Why? Because this there only refers to what happens at a single port. That is why, because reflection coefficient are the diagonal elements of the S matrix only refers to what happens at a single port. Your S11, S22, say if I take a two port network, you will be getting S11 and S12, S21, S22, right? The matrix it is. Here this S11 and S22 are called as your diagonal elements of the S matrix. So here you can see it is corresponds to only one port, S11. Both input also you get giving at the port 1, output also you getting it from the port 1 itself. Here also it is input you are giving at port 2 and output you are getting it from the port 2 itself. So that's why these diagonal elements are referred to as reflection coefficients. Okay, while the off diagonal, that is non-diagonal elements, whatever it is there, so that corresponds to it is transmission coefficients. This refers to transmission coefficients. Why? Because they refers, see here you can see this S12 and S21. These two are called as non-diagonal elements over here, and this corresponds to transmission coefficients. Why? Because they refer to what happens at one port and when it is excited by a single incident at the other port. So you are giving input at port 1 and getting the output from the port 2. Okay, so here you are referring to both the ports here. So that's why it is refers to transmission coefficient. So in the diagonal elements, whatever it is there, that corresponds to reflection coefficient of diagonal elements for transmission coefficients. How I can write the different matrix for different ports? Say I have a matrix, I have to write a matrix for one port. How I'll write? So it will be S11. Single port it is. So you are giving the input and getting the output. Two port means two terminals you will be having, no? So two port, you will write it as S11, S12, S21, S22. So I have to write for three port. Three different ports you are having. So how will I write matrix? It is S11, S12, S13, S21, S22, S23, S31, S32, S33. So this is how we'll write for different ports. Say you have four, you can write. Say if I consider n port, that also I can write. Yesterday I have shown you. Correct? S1n, S1, 2, sorry, S11, S12, S13, it goes on up to S1n. Again you come back here, S21, S22, sorry, S22, S23, it goes up to S2n. It can extend up to SN1, SN2, SN3. So this goes up to SNN. This is for n port. Like this, you can write for any number of ports. The S matrix can be written for any number of port. So each S parameter is a complex number where actual data present in complex format and phase angle would be present for Sij. Okay, each S parameter is a complex number. So where actual data present in complex format and the phase angle would be present for Sij. So your Sij represents your complex number, that is nothing but your S parameter. So S parameters describes the response of an n-port network to a single, sorry, S parameters describes the response of an n-port network to a signal incident to any or all of the ports. So you are finding the response of n ports for a signal incident at a single port or all the ports for a incident wave. Okay, so then the first number in the subscript refers to the responding port, while the second number refers to the incident port. Okay, thus S21 means the response at port 2 due to signal at port 1. Yeah, so Sij means if I say take S21, this represents that you are measuring response at port 2 due to signal at port 1. So this S12 means that response at port 2 with respect to the signal at port 1. Okay, here I said ulta, I guess, no? This is how you can say is S11 means it is response at port 1 due to the signal at port 1 itself. Port 1, this it represents where you are taking the output and with respect to which input. Okay, the same thing. Sij, this is output, input port only, but output where you are measuring with respect to the input at which port. Okay, so that is what here S21 refers to response at port 2 for a signal at port 1. Say you have S32. If I take this 3-port network, you have S32, right? This is response. This represents the response at port 3 for the signal incident at port 2. Okay, this is what it meant. Okay, the most common n-port networks in the microwave networks are, it is 1 port will use, okay, and 2 port, 3 port. These are the most commonly used n-port networks. N here it is n means you can take number of ports. So n, it will be having the range from 1 2 3 up to n. So till 3 you can refer for microwave networks. So okay, and these S parameters are very easy to model with the software. So these S parameters are very easy to model with the software, but measurements are difficult to perform. Measurements are very difficult to perform and to get the accuracy. So this you can take it as an advantage. Very easy to model with the software, but not the measurements. With respect to measurements, it is very difficult. So we'll conclude this S introduction to S matrix. So it is where you are using S parameters are for radio frequencies and the microwave frequencies, where you can quantify the energy and the power. You are considering energy and power, not the current and the voltages. Okay, so S parameters are nothing but your scattering matrix of the microwave network. So it is a mathematical construct that quantifies how RF energy is passing through the multi-port network. So it is a complex number where it is having both the magnitude and the phase. So it is having, so how the matrix format is, it is with the number of rows and columns which are equal to the number of ports. So if you have you have 3 cross 3 matrix means 3 cross 3 matrix means you have the number of ports is equal to 3. 1 cross 1 matrix represents it is 1 port. So that is what this statement is. Okay. And the diagonal elements represents the reflection coefficient. Half diagonal elements represents the transmission coefficient in a S matrix. So this is what we had discussed till now. Now we'll see what it is two port. Till now I had explained the general. Okay, so explained the general S matrix. Now we'll consider two port network and see how we can write for two port. So next we'll consider two port network. A signal at port 1 can be thought of as superposition of two waves traveling in opposite direction. That is, by convention, each port is shown in figure. I'll write the figure here. See, I have a two port network. This where you know how to write S11, S12. Say it is defined by the S matrix like this. This is your incident wave and the reflected wave B1. Here you have incident wave A2 and the reflected wave B2. So that is what the signal at port 1. So this is port 1 and port 2. The signal at port 1 can be thought of superposition of the two traveling waves here, one each in opposite direction. This is A1 and B1. Okay, so we have taken two nodes here, that is 1 and 2. Okay, the a variable AI, say I'll take variable AI for n port. So if you have a multi-port or n port network, if I consider AI, this represents wave incident to port I, and variable BJ represents wave reflected from port J. So this is incidented and this is the reflected from port J. The magnitude of AI and BJ variables can be thought of as a voltage like variables normalized using a specified reference impedances. So this is very convenient since the square of these magnitudes are then equal to the power level of this waves. So the magnitude of this AI and BJ variables can be thought of voltage like variables. We can take these two variables as like voltages. So these are normalized by using a specified reference impedances. So this is very convenient since why? Because the square of these magnitudes are equal to the power level of the waves. This we had seen in the previous classes. Correct? The square of these two will give you the power. Correct? So what we are discussing, the S matrix or S parameters, that doesn't mean anything or it is useless if you don't know the value of a reference impedance. You should know the reference impedance, then only the S parameters are having any meaning. That means the S parameters don't mean much unless we know the value of the reference impedance. If you don't know the value of the reference impedance, so S parameters are nothing. You can't do anything with the S parameters. Okay, this is for two port network, especially for two port network. So you have A1 and A2 as incident matrix, B1 and B2 as A1 and A2 are incident waves and B1, B2 are reflected waves. So if you are writing it for AI represents wave incident to port I. BI represents wave reflected from port J. Similarly, if you write it for excuse me, in a multi-port network or n-port network, if you're considering means, say if I write A3, so this represents a wave incident to port 3. If I write a B4, so this is the wave reflected from the port 4. So if you don't know the reference impedance value, so S parameters will not mean anything. Okay, you can't do anything with the S parameters. Now we'll see how you can find the values of